Apart from classifying differential equations as ordinary or partial, they can also be categorized from their order and degree. Check out how to identify their order and degree here in Engineering Math 5. The order of a DE is identified as the highest level of the derivative present. Such level is also termed as the differential coefficient. In the equation shown, there are two terms with derivatives. The first is the third derivative, and the second term is the first derivative. So in this case, the order of the differential equation is 3. In case there are more superscripts in the differential equation, such as the one shown, the equation is the fourth power of the second derivative of y with respect to x plus the derivative of y with respect to x is equal to e raised to negative y plus 2, where the first term has so many numbers on top. So as not to get confused, remember the definition of order, which states that it is the level of the derivative. So take 2 as it is the second derivative compared to the first derivative in the second term. So the order of this DE is 2. Moving on with the degree of DEs. The degree of a differential equation is defined as the power of the highest order derivative. Since we are looking for a power, the equation should be treated like a polynomial. For example, we have the third derivative of y with respect to t plus 4y times the derivative of y with respect to t is equal to e raised to y. If we consider this as a polynomial, we note that the first term is just raised to the first power, although it is the third derivative of the variable. The second term also is in the first power. But another thing to consider is to focus on the derivative of the highest order, so we stick to the first term. So this DE is of order 3, but just with a degree of 1. Let's check the degree of the previous example we had. First, identify which term has the highest order. And in this case, it would be the first term. Then determine the power of the term. We can see that the whole term, which includes the derivative, is raised to the fourth power. So the DE's order is 2 and its degree is 4. How about this trickier DE? You can notice that the left term is raised to 4 and the derivative on the right is raised to 2. Do not act rashly and take 4 because the other condition is to identify the highest order derivative, and in this case, that would be the third derivative of y with respect to r, which is in the right term. So the degree of this DE is 2 and its order is 3. One more thing to remember for the degree of DE. We mentioned earlier that the equation would have to be considered as a polynomial function. So in the differential equation presented, the second derivative of r with respect to t plus sine of the second derivative of r with respect to t is equal to 10r. Since the second term is a trigonometric function, the degree will then be taken as undefined. So its order is 2, but undefined degree.